So with the normalization of charges, I've used the +1, -1 for the positron and the electron, and a charge parity calculation for the quarks, for the proton and the neutron. And if we kind of step back from that normalization and we really kind of dig into the idea of what charge actually is with respect to the electron. So the supersymmetry inversion model doesn't use a point-like source for the electron. It kind of goes beyond that, and it uses some numbers associated with a spherical particle for the electron. So in the He-BEC singularity model, the electron has a diameter of 4e to the -18 of a meter. It's obviously smaller than any photon that we've gained access to in terms of the gluon field, which is around 10 to the -16 of a meter. So if the photons that we have access to kind of look and measure things are larger than the electron, then we can't actually measure the size of the electron. So we've got this Compton wavelength of the electron that's determined based on the measurements that we've made. And I've kind of gone, well, I'm not going to use measurement. I'm going to use a theoretical framework for what an electron actually is, and that's come from the He-BEC singularity model. And so I use the inverse square law relationship between the Planck scale, which is 1.6e to the -35 of a meter, and the square root of that gives me 4e to the -18 of a meter. So I'm using two Planck lengths side by side as the idea of an electron, as the diameter is h squared. You would go, well, that's h times h is not 4e to the -18. So I develop a inverse square law relationship. So you have to square root when you've got two h's next to each other. So it's a little bit kind of working counterintuitively with very small numbers. So if you invert them, put one over a small number, we get a big number. So I'm playing with the idea of inverse square law, Newtonian physics for gravitation, gravitational force between two point-like sources, or between the electron and the positron within the structure of atoms. So here we have, we've got our charge of 1.6 e to the -19 coulombs. And I've been looking at ways of investigating that. So I've got, we know the circumference of a circle is 2 pi r. We know the area of a circle is pi r squared. We know the surface area of a circle is 4 pi r squared. And we know this volume of a sphere, the surface area of a sphere, 4 pi r squared, and the volume of a sphere, 4/3 pi r cubed. So I've done those calculations, right? So I've got pi is 3.1415. I've got K97. K97 is 5.00e to the +8. Okay, so what I've done is I've taken my diameter of the electron, basically taken the Planck scale, square rooted that to get 4e to the negative 18 as the diameter of the electron. I've inverted that to give me 2.5e to the plus 17 meters, taken the square root of that to give me 5e to the 8 meters, and then again inverted that to 2e to the negative 9 meters. So I play around with inverse square law models, and then I've looked at the surface area of that sphere based on the 5e to the 8. Okay, so that is a relationship to the diameter of the electron through an inverse square law. And what we get, okay, here's the weird stuff for the surface area of the sphere. And 4 times pi times r squared, so r being, in this case, 5e to the plus 8. Okay, 5e to the plus 8. And what I'm getting is 3.14e to the plus 18. Okay, so you go, well, how does 3.14e to the plus 18 relate to charge of 1.6e to the negative 19? And what I do then is I invert that number, right? I've inverted the number, 3.14e to the plus 18. 1 over that gives me 3.18e to the negative 19. Okay, so that's what? Now we look at the inside surface area of the electron sphere and the outside surface area of the electron sphere, and we add those both together, and we get 3.2e to the negative 19. And here I have 3.18e to the negative 19. Okay, they're not identical, they're not perfect, but they're pretty close. Pretty close. Okay, so what I'm saying is that here we have a model, and it is just a model, but it's a model that relates inverse square law relationship of point particle. No, electron's not a point particle. It has structural features associated with inverse square law. So we've gone from Planck scale, and then we've gone the square root of that to give 4e to the negative 18 of a diameter of the electron in the model, the supersymmetry inversion model from the He-BEC singularity. And then we've square rooted that. And what do we get? 5e to the plus 8. So this relationship of inverse square law gives functional information in relation to the surface area of a sphere that corresponds to the Coulomb's charge. So the actual electron charge is spread out over a area, and that area corresponds to the inside surface of that sphere and the outside surface of that sphere. Guess what the separation is? The separation is alpha, the fine structure constant. So what we're finding is that this relationship has aspects of information, and that information's conveying structural features of an electron. So not only are we able to then go, okay, here's an inverse square law model that's providing information on the surface area charge properties of an electron and a positron. So then we've got an idea of, well, how big are they? Yeah, we do. We do have a model that actually shows how big an electron is based on the square root of the Planck scale. And that's a fascinating thing, because we've utilized the idea of charge on an electron as being -1, and here I'm saying, well, if you do the square root of the Planck scale to get 4e to the negative 18, and then you square root 4e to the negative 18 to get 5e to the plus or 2e to the negative 9, or 5e to the plus 8 as the inverted, right? What we're seeing is that is actually related to the surface area of a sphere. That's just a phenomenal piece of the jigsaw puzzle to actually go, well, we can actually go back to the Coulomb's charge and now understand the fundamental reason why charge on the electron is that in terms of Coulomb. So Coulomb's is a surface area of the electron with a radius of 2e to the negative 9 of a meter. And that just doesn't make sense to anybody, but that's what the numbers specify. If you do 4 pi r squared calculation of 2e to the negative 9, then you'll end up with 3.18 e to the negative 19, and that's essentially double the 1.6 e to the negative 19. So we're building models, and those models that we're building is based on fundamental calculations that provide a framework to look at the universe, not through measurement, but through mathematical calculations that predict the universe. So we've got all these results based on measurement, and now we're kind of going, well, how do we use an understanding of how the universe operates to actually get the outcomes that we have? And so it's really pulling back further layers of complexity, but also a way of kind of lifting a veil in order to understand the universe in terms of operating parameters, functioning, and, well, here's a way that the universe generates charge based on the surface area of the electron, based on the surface area of the positron. Now we have a way of going, okay, if that's what the universe is generating, then why do we have mass? Why does a proton have more mass than the electron? And rather than looking at the idea of the Higgs field, we're looking at proximity to the singularity within the atom, the origin of the atom, the inertial frame of reference, 0, 0, 0, XYZ. It's a way of exploring what does that singularity look like within the atom. And I'll do my next little video associated with that. Thank you.